Hello everyone, Samuel here, and today we are going to be learning Rust. This is going to be a comprehensive tutorial for you to understand the basics of Rust, and at the end of this tutorial I expect you to master how to use Rust to build a simple application. So let's dive in, but before you proceed, make sure you hit that like button and also the subscribe button. So Rust is a modern programming system language designed for performance, safety, and also concurrency. It was initially developed by Mozilla and has gained a significant popularity in the programming community. And Rust is used in web development and also in blockchain development. It's often compared to a language like C# and the C++, but Rust is a little bit special because it comes with a built-in safety features that help prevent common programming errors. Rust is a versatile language and used in various domains like web applications, blockchain application, and also other performance critical applications. It's also used to build embedded systems where resources are limited. Many developers also use Rust to create command line tools, which are actually fast when you are interacting with them. In this crash course, we'll cover the fundamental concepts of Rust programming language. You will learn about Rust syntax and basic programming constructs such as variables, functions, and control flow. We'll also dive into Rust's unique ownership and borrowing system, which is central to the language. We'll also cover error handling, data structures, structs, and enums, and also pattern matching. This course is divided into multiple videos, each focusing on an aspect of Rust programming language. The first full video will introduce you to the basics, and as we progress, we will tackle more complex topics. By the end of this course, you will have an understanding of Rust and be ready to explore more advanced topics on your own. The course is designed to be a hands-on, so you are encouraged to code along with the tutorials to get the most out of it. In order for us to get started, we have to visit the Rustlang website. So just copy this URL or just type down this URL on your browser and you are going to get exactly the same page as mine. So the next thing is to click on Get Started. And this will allow us to install a toolchain from Rust called RustUp. So the installation process works the same for Windows, Mac OS, and also Linux. The RustUp allows you to easily manage Rust versions and toolchains. We'll also introduce you to Cargo, a Rust package manager and build system which we use to create, build, and manage your project. I'm just going to copy this and paste that on my command line interface. So in case you already have Rust installed, it's the same process. What it's just going to do is to help you to update to the latest version of Rust, and there is not going to be any conflict. So, but for the new beginners, please go on and copy this and paste that on your command line interface or your terminal. So I'm just going to copy that and paste that. And then I'm going to press 1 and hit enter and then give it some time. So right here, you could see mine was a little bit faster than yours, probably because you don't have it on your PC. But for mine, I also have Rust on my PC installed. So right here, you could see it was fast, but yours is going to take a little bit of time to get everything installed on your machine. So after the installation process, we are just going to run this command, rust c version, and it's going to display the latest version of Rust as of the time of you watching these videos. So this is the latest version of Rust as of the time I was making this video. You're going to see something similar like this on your terminal. In addition to that, we're just going to run this command to ensure that we have the package manager also installed on our PC. And then we also get the same version. So quickly, I'm going to clear this up. I'm going to make a directory called Rust Sandbox. So I'm going to switch inside this Rust Sandbox and open my Visual Studio Code right there. So the first time you're going to try to, let's say, create a Rust file and then open that on your Visual Studio Code, you're probably not going to get your Visual Studio Code recognize that. So what you're going to do is to install an extension called the Rust Analyzer. So install this extension and it's going to automatically help you to recognize the Rust syntax on your PC. So it also helps with auto recommendation. Let's say you're working with multiple enums. When we get to that part, you will see it in action. It will help you to kind of auto recommend things for you, and you can easily be efficient when you're writing your codes. So what I just showed you is one way to create a Rust project, but we do have other ways of also creating a Rust project. So let me just give you an example. So let's say I don't have this Rust sandbox right now. So I can just say cargo new, and then I can just type down Rust sandbox, and it's going to initialize and create a new Rust project, which you could see right here. I can switch into that and also open that on our Visual Studio Code. So I think I made a little bit typo there. So let me just be correct on that. So you could see it also creates a project for you. So another way to also create a project, let's say you already have that Rust sandbox folder created, and you want to actually create a project inside that same directory. So what you could do is, sorry for that. What you could do is to switch inside the Rust sandbox, and then you can just type down cargo init and then hit enter, and it's still going to create the project for you right there. So when we open this on our Visual Studio Code, we also see something, the same thing rather, in the same folder. So in order for us to run our project, we have to build it by just running cargo build. And this is going to build the project down to the target directory. And right here inside the debug folder, you're going to see the Rust executable file. So if I just run target /debug/ Rust sandbox, it's going to execute that file, and we can see exactly what we have here. So if I say hello world, for example, and then run cargo build once more, and let's say, sorry for that, let's say I run back that target file, which is the executable file, is going to automatically get this for us displayed. So another way to build and run our project is very simple. It's just to run cargo run. So this will automatically build everything and then also run it for you on the command line. And lastly, when we want to build for production release, all we just have to do is to run cargo build with the release flag. And this is going to create one more folder called release right here inside the target folder, and we can see the optimized version of the executable file on the release folder. In Rust programming language, macros are like recipe shortcuts. They let you create reusable code snippets that you can use in different parts of your program. This helps you write code that are easier to understand, read, and also maintain. Imagine you are writing a recipe book. Instead of writing out the same steps for styling in every recipe, you could create a style macro. This macro will be a shortcut that you could use in any recipe to automatically write the steps for styling. So the first macro we are going to talk about is the print macro. Of course, Rust has a lot of them. So with the help of the print macro, we can print something in our terminal. Let's say hello world. And then all we just have to do is to run the cargo command, and that is going to build our project and also print out the hello world on our terminal. A mod keyword is used to define a module. Think of a module as a container that groups related functions, structures, and other items. This helps you organize your code into logical units, making it easier to manage and understand. So let me just give you a very good example. We are going to move what we have in here into a print file. I'm going to quickly create that print file, and I'm going to copy this and create a public function called exec. I'll paste that right here and save. So in order for us to make use of what we have right here, which is the exec function, I'm going to use the mod, and then I'm just going to write print, and it will automatically recommend that with the help of Rust Analyzer. And for me to execute this function, all I just have to do is to come right here and call the print module, and then I will get recommended the function exec and just hit enter and save. And once I run the cargo command again, it's going to compile and give me that same result. There are other ways for us to make use of the print line macro, and one of them is called the placeholder style. So let me just quickly put this down, the placeholder style. So what it just does is, let's say we have the print line, and then I'm going to put down a placeholder, and then whatever I type here will be used to replace this placeholder. So let's say hello world, and then we save and run the cargo run again. And right here you could see automatically it takes the word and replaces that on the placeholder. So let's sort of print a math operation. So let me just declare a variable called results, and in this result I'm just going to say 5 plus 10 for example, and we can print line the result is, or let's say the result of 5 plus 10 is, then we add a placeholder and then we just pass down that result, and automatically when we also run the code, so let me just sort of comment this out so that it doesn't distract us. And then I'm gonna run the cargo command, and the result for 5 plus 10 is 15. We also have another one which is print with positional arguments. So let's say we bring down the print line, then we can say let me just give this like a name. Let me just give name an object and a place, for example. So let's use Alice, let's use Wonderland. Because it's a place, I'm gonna use the uppercase. And then what does Ali love doing? Alice love to explore. So let's say we're just gonna reference the first placeholder loves Alice from Wonderland loves to, oh sorry, this is supposed to be the one placeholder, loves to explore, which is the second placeholder. So we can comment this out, and then we can run the cargo command, and then Alice from Wonderland loves to explore. So we also have named arguments. So instead of us using like indexes to reference this, we are just going to use named arguments. So let me just give you an example. So we have the print line, and for example, let me just put the name argument first, and then we're gonna declare that. So we have subjects, we have verb, and object. So subjects equals, let's use this popular example, the quick brown fox. So let me break this down so that it can show very well. And then we just have to add the verb jumps over, and we have the object, which is the lazy dog. So let's save these and save. So I'm just gonna comment this out so that we can get a clean terminal, and then cargo run. So you could see the quick brown fox jumps over the lazy dog. So let's print a debug output. So this is a little bit different from the way we print the other ones. So let me just give this print a debug output. So let's just use something like a tuple, for example, and then we can assign different values, maybe a string, hello, and a float. And for us to print this, we are not going to print it like this. So the way we can do that is to use the print line, and then what I'm going to do here is to bring down the tuple. But for us to make sure that this prints perfectly here, we have to use a debug style, which is a colon and also a question mark, and then we can save that. And once we proceed to run the code, it's going to print exactly what is inside here. So this is a mixture of different type of values. So I'm just going to run cargo run, and then we get that same tuple printed for us on our command line. So this is just a basic example of how to use print line. We do have another way of printing things on Rust, and let's go over to that. The format macro is used to format text, just like the print line macro. But instead of printing the text to the console, it returns a formatted string. Let me just go on and give you a very basic example. So I'm going to create a file called format.rust, and then I'll create a public function called exec. And then I'll bring that module of format file down here. And what I'm going to do is to comment this out, and then I will bring down the format module and then make reference of the exec function. So quickly right here, the basic example I'm going to give you is to use a sort of placeholder style to print something using the format macro. So let me just declare a name here called Bob. Let me declare an age as well. Let me just use a number instead, let's say 25, and then let's say a sentence that makes use of the name and age, which is gonna be equal to, then we can make use of the format macro, and then we put our string, and then we can pass in our placeholder values, which is name and age. So we can say Bob is how many years old, which is 25. So let's save that, and what we're gonna do is to use the print line macro to show that. So we can now pass down our sentence. So with the help of the format tool, we were able to join this together as a string, and then we use the print line to actually display that. So once I run the cargo run, we should get that same result right here. So we are getting this because we are not making use of the print line. So whenever you have a redundant function on Rust, you are gonna get this yellow line under it. So that's just basically why we are getting this. It's just like a dead code or something that is redundant. So don't worry about that. So usually when we are programming, we always have to declare variables. So we've been actually declaring variables when we were talking about the print macro. But let me just go ahead and declare one more variable. So let's just give this as 3.5 and save. And we can always print that on our terminal with the help of the placeholder, and then passing the placeholder value right there. So even if I go on and run this cargo run, we are gonna get 3.5. So right now this variable right here, it's immutable, which means we cannot reassign it. But I'm gonna give you an example that makes you pretty understand what I'm talking about. So let's just go ahead and declare something like a name called Rust, and then we can say print line programming language, and then we can pass our placeholder. So once we go on and run this, I think I'm getting something wrong here because I didn't pass the placeholder, which is the name for the name. Then once I run this cargo run, we're gonna get programming language Rust. Then let's say I want to reassign this name to let's say another programming language like C++. So Rust is not going to allow that because Rust is going to tell us that value assigned is I want to get that error particularly. So consider making this binding mutable, which means we cannot reassign this variable, and it's I think I want to say that, yeah, say cannot mutate an immutable variable. So for us to make sure that our variable can be changed, all we just have to do is to add mute to it. So a simple example I will give you is, so let's declare a mute variable called score, and I'm going to assign a number to it, and then I can actually add a number to this score, and I can reassign this score to something like, let's say 150. So once I print line, and then I'll pass the placeholder value. So we're just gonna comment these out so that we don't get an error when we run our codes. So right here we have the score, and then we added an extra 50 to it, but we can also reassign let me just use another value right here, like 200, and then when we run cargo run, we are supposed to get that 200 printed. So with the help of the mutes, we're able to reassign values to our variable. So we can even go on to shadow a variable. Let me just give you an example. Let's declare an x equals to 2, and let's declare another x. So what we're going to do is to use x plus x. Let's say x plus 2 or x plus, let me just use x times 5, for example. So this is going to shadow this variable, and this is going to add a new variable. So we can print line, and let's say value of x is, and then we can pass that as a placeholder value. So what I will do is I want to remove this and then clear this. So let's run that. Let's kind of comment this out because I don't want to see this yellow line. But right here you could see the value of x is 10. So it's sort of shadowed this variable, and of course in Rust there is no conflict about this, and I pretty kind of like it, but you have to be very careful when you are shadowing a variable in Rust so you don't make mistakes. So let's go on and declare a constant. So I'm going to declare a constant called pi. So pi is 3.14159. So when I declare that, I have to infer the type, which is F64. So we're going to come to data types so that I will kind of explain the data types to you. So I can print that as well. The value of pi is, and then I'll pass that pi as a placeholder value. So usually when you declare a const, you also have to infer the type in order for you not to get an error. So sometimes you see me making mistakes. It's been a while since I dropped a video course, but I'm trying as much as possible to eliminate that, and I hope you go with the flow. Thank you. So please make sure you hit that like button and also the subscribe button. Then if we go on and run this code right now, the value of pi is 3.14159. We also have a multiple way of declaring variables. So think of it as holding values in an array, but right here we just say a tuple. We use a tuple, something called a tuple. So let's say multiple variable declarations, and let's say x, y, and z, and then we can assign different values to it. So this is actually cool because it can help you hold as many values as it can be, and automatically it infers the types. You could see Rust is kind of shadowing the types to us. And if we want to print that, we use the print line. We can say x is, y is, and z is. So what we're gonna do is to pass down the x, y, and z, and automatically we can still get that printed for us. So we have x10, y20, and z30. So that's it for variables. And if you are a little bit confused or you don't know what to do, always put down something on the comment section and I will attend to that. We are going to focus next on data types. So in Rust, we have different kinds of data types, but we're going to start with scalar types. So scalar types in Rust represent individual values as opposed to compound types like arrays or structs. Integers are one of the fundamental scalar types in Rust, used to represent whole numbers. So for example, if I type down temperature, for example, and say this temperature is 10, Rust is going to automatically infer a data type, which is a signed value of 32 bytes to it. So if I, let's say if I manually set this by myself, it's still going to work. But if I change this to a float and try to use this data type directly on that variable value, we are going to get a red line showing us that this is not going to work with a signed value. So we have different kinds of data type. We have the 8-byte, we have the 16-bit, we have the 32-byte, 64, we have 128, and we have I size. So these are like examples, but I'm just going to give you some basic example for you to understand more about this data type, and you can make more research about that. I'm going to list down some of the variables and the limits they can actually take in based on the data type. So let's say, for example, we have let me just put this down on the tuple. We have I8, we have I16, we have I32, we have I64, we have I128, and we have I size. So each of these data types has limits. Let's say, for example, for I8, it can only take in values from -127 up to 127. So any value above this is going to give us an error. So let's quickly give an example. Let's say, for example, temperature is let's give it an I8, and then let's try to set this to the normal value. Let's say 100. It's gonna work, but if we try to set this to like 200, we are gonna get a red line because we've exceeded the data type that this can intake based on the infer type to it. So sometimes this is very good for memory consumption, for you to manage your memory. So I wouldn't want to dwell too much on these limits. You can actually go on and make some research to learn more about it. So one of the things that signed integers does is it can accept both negative and positive value. Let's say we have temperature once more, and then we have an I8, so we can go to like -10, and it can also take in like positive numbers, but we can't take floats because this is not a floating type of data. So everything we talked about here are called signed integers, but we also have to have unsigned integers. So unsigned integers normally don't accept they don't accept negative values. So they are just similar to everything we have right here, just that they are called unsigned integer, which means they have to always be positive at all times. So I will also encourage you to make a little bit of research to have more understanding of how this works, but I'm going to give you a very basic example. So let's declare, let's say, age, and in this age we are going to use a U8. Always remember the limit when you are dealing with the types. So we have, for example, 30, and then if we try to change this to a negative, it's definitely we're gonna get an error because it has to be positive at all times. So let me just print this and say, let's kind of make this a little bit more interactive. Age is, and then we can pass the age value for our placeholder. So another kind of data types, they are called floats. So let's declare a float. So floats don't accept of course whole numbers, so there must be a point, a decimal in between these numbers. So let's declare something like what am I gonna say? Let me just comment this out because I like using the word temperature a lot. So I'm gonna say this is a float integer of 32 bits rather, and then we can give it a number. So if we try to make this a whole number, definitely we're gonna get a red line because it's not supposed to be like that. So let's make it a little bit interactive again and say body temperature is of course I can actually put that right now, but I think you understand what I'm trying to do. If you're a chemistry student, you can actually put that. So this actually works pretty fine, and if we run cargo run, we should actually get all this printed on our console. So let's wait a little bit for this to build. So you could see body temperature is this and the age is that. So let me just bring this down a little bit and clear this. And then we also have booleans. So booleans are like true or false. Declare a boolean, and let's say it's active. So right here we have to set bool data type. Of course, you know this won't accept any numbers, so it's not gonna work because it's definitely a boolean that we need. So we have to change this to true, and then let's also make it a little bit nice. Is the system active? Let's add that placeholder. We can choose to use debug or anyone, but rest assured this is going to also work perfectly. So we can save that, and even if we run cargo run, it's going to work fine. So I'm not going to spend time running cargo run. I think you really understand how to run your code right now. So we can also declare a character. So let's say letter is R. So we can print that and say the letter is letter. Then we can also declare I think I already showed you on signed integer and signed integer, but let me show you something called a tuple. So when we declare a tuple, we can actually infer types to that tuple. So let's say let's just say it's a complex thing. So declare a complex data type, and then we're gonna say compile complex number, not compiler. So complex number. So we have 2.0, we have 3, and we can actually have a string, which is let's give it something like hello. So right here you could see Rust is already inferring that automatically, but what we can do is to manually infer that. So this is going to be an F64 because it's a float number, or we can use an F32, anyone we want to use right here. So let's use F64. We can actually infer a data type directly on that as well. So this can be I8 or I32. Remember, there's no limit for now because we have 3, which is way beyond the limits of the scope of the types, and then we have one more, which is a string. So all you just have to do is to add string to it. And even if we print this out, complex data, so we have this and this, which we can actually say complex complex.0, complex.1, and complex number.2. So actually use complex number. That should actually be complex data. Yeah. And when we run cargo run, everything gets displayed. So complex data 2, 3, and hello. So that's just it on data types, and I hope you learned a lot. So before you proceed, hit that like button and also the subscribe button. So far we've gone through some of the most basic things on Rust, but now we're going into a little bit more intermediate level type of things in Rust, and these ones are things that helps you build applications effectively. So I'm going to close this and comment this out as usual. I'm going to create a file called Conditionals. So I'm making a lot of mistakes because it's been a while since I dropped a video course, but I'm trying to minimize that and I want you to bear with me. So I'm going to create a function called exec once more, and as usual we are going to come right here and bring in our conditionals, and quickly we can use our conditionals and then call our function exec. So inside this exec function, I'm going to show you what are called basic if else statements. Basic if else. Let age is equal to 18, and well, what we're gonna do with the if else, if we're gonna check if age is greater than or equals to 18, and we're gonna print something. If not, we're gonna print something else. So if age is greater than or equals to 18, what we're gonna do is to print line. You are eligible to vote. So if age is not greater or equals to 18, we have to add a fallback print line. So these fallback print line are things that will always print whenever we don't meet this criteria. So we can say you are not eligible to vote, and we can save that, and once we run, we are gonna get you are eligible to vote because our age is greater than 18. And don't forget, you can also infer type, or you can use a recommendation from Rust, which is actually a good way to help you also minimize inferring types errors. So let me say I change this to 19 and try to run that code. We're gonna get sorry for that, we're gonna get you are not eligible to vote because right now the age is not meeting this criteria. So we have if else with multiple conditions. And what we're going to check is if a number is divisible by 3. So let's say a number is 15, and if this number is divisible by 3, we actually get 0. So if you're coming from other programming language, you kind of know something similar as this. So if it's divisible by 3, the answer is going to be 0. So whenever we get 0, we want to print something down. So we can say print line number is divisible by 3. But what if this number is not divisible by 3? We can use else if. So let's say we can also check if this number is divisible by 5, which is 0 as well. And we can bring that down here and just say this is divisible by 5. And then we're going to have a fallback in case it is not divisible by 3 or 5. We're going to have a callback print line. So we're just going to add an else, and we're going to print line right here, and we can say number is not divisible by 5, but let's say by 3 or 5 rather. So let's go on and run this. So we get number is divisible by 3. So let's kind of add something like is a number that is divisible by 5. Let's say 25, for example, and cargo run this, and we say no, we get number is divisible by 5. Then let's get a number that is not divisible by 5 and 3. So we get okay, 3, yeah, 27 is still divisible by 5. So let's use something like 28, I guess. Number is not divisible by 3 or 5. So that is multiple condition of if else statements. So another way for us to use conditional is using it directly on a variable. So let me give you a very good example of that. So let's declare a condition called true. So this condition, we can assign a bool to it, and then let's declare a number. So what we're going to do is we're going to check if the condition is met. We're going to return 5, else we're going to return 10. I have to add an equal sign there and then save. So don't be confused. This is actually a way Rust can return something by default. So I don't want to be carried away now, but when we get to functions, you're going to understand what is going on here. So we can say print line the value of number is, and then we pass the placeholder value. So I think it's best this way, which is the number. So let's go on and run this. And we get the value of number is 5. We do have a way to use ternary operator in Rust, and if you're coming from a language like JavaScript, you understand that ternary operators are like, let's say we have a condition and we met that condition, we get the results right here, and then if there is no result, then we have a fallback that we have to use. But in Rust, we actually did something similar like a ternary operator right here. But in order for you to like understand more about that, let me just give you a very good example that we can still use to elaborate our understanding on that. So let me clear this. So I think we have to reduce this a little bit because it's getting too big for us. So what we're going to do next is declare a variable. So let's is even equals to, so what I'm going to do, I'm going to use this number right here. So we are using a condition that returns a number 5 or 10 if this is true, but you know it's going to return true because we have a condition of true. So I'm going to use that number here so that we don't actually waste a little bit of time. So I will say if number is divisible by 2, which is going to give us 0, we have to return that that number is even, else that number is odd. I'm going to save that. So if we print line and say the number is, I guess you already know the number is odd, so let's quickly print that. So if we run cargo run, and you could see the number is odd because right here we are returning 5. So we are sort of using ternary operators right here because it's a one-liner thing and it returns a single value or a fallback value. So that's just a basic example of ternary operator in Rust. Then in Rust we have the match conditions. So I call them the match statements as a conditional. So let's declare a weather and say the weather is sunny. Then what we're gonna do is to match whether the weather is sunny. So we're gonna match the weather. So this is more like a switch statement. If you're coming from like JavaScript, you already know the switch statement where you can add different case based on the value that is being matched. So whenever it's rainy, for example, we're gonna return this, which is the print line. You can actually return a string depending on how you want, but rest assured it's not gonna display anything, but the best thing we can do is to print something. So we kind of print line take an umbrella. So whenever it's rainy, we take an umbrella. Whenever it's sunny, I guess you already know this is what we're gonna get because the weather is very sunny. So you wear sunglasses. And we always have a fallback on switch statements or on match statements. So which is gonna be print line check the weather. So sorry, I missed something here, so you have to always add an underscore right there. So with that done, if we run our code, so you could see wear sunglasses because the weather is sunny. So that's just a very basic example of how to use the match statement. And if we change this to rainy and run that, you can see take an umbrella because the weather is rainy. And let's say there's nothing, let's say wind, the weather is windy or wind, something like that, and then cargo run check the weather. So this shows us how to use the match statements to actually perform some conditional operation when we are running our codes. So the last example I'm going to give you on this conditional is called a nested if else. So let's declare an age. So even if we have an age declared, that will be like a mirroring, but you already know this is going to override that initial value. So we can say if age, sorry, we don't add parentheses. If age is less than 18, we have to print line. We can say this person is a kid or a minor, and else if age is greater than or equals to 18 and age is less than 65. So we already know this person is an adult. And lastly, we always have a fallback print line in case none of those matches. So we already know that this is a senior. So by default, we already have seniors. So seniors are 65 and above. So when we run our code, I guess you already know that that should be around an adult, I guess. So you can see adult. So go around and sort of change these numbers to understand more on how the nested if else statement work. So far we've learned about conditionals, and if you've gone this far, hit that like button and also the subscribe button. So loops allows us to execute things recursively until a certain condition has been met. And in Rust, they also are similar to other programming languages. So we're going to start with an example of while loop. So what I'm going to do is I'm going to declare a mutable number because I want this number to be decreased. That's why I added the mute to it. But we're going to start off with 3, and we're going to say why this number is not equals to 0. We're going to do something. So the first thing we're going to do is to print the number as it's counting down. And then what we're going to do is to start reducing this number. So I'm going to use minus equals 1. So what this does is going to actually decrease this number until this number equates to 0. So we can now print, let's just print something at the bottom called lift off. So if we execute this right now, this code is going to work until we get to 0, and then we print lift up. So you could see we have 3, 2, 1, and then lift up. So this is just how while loop works. So we also have the for loop, which is going to use to loop through a certain number. But what I'm going to do is I'm going to create a range of numbers and then use the for loop to loop through it. So let's say using a for loop. So we could say for number in, so I'm just going to create a range, let's say 1 to 4. You can actually create 1 to 10 depending on how you want it, and then you can print line. You can add that, and then you can add a number. So we can also print lift off as well. So when we run this is going to work perfectly. But right here you could see this number started with 1, 2, 3 up to 9, and then we printed the lift up. So what we can do is actually reverse this number. So the way you can do it is to add this on the parentheses and then dot ref. So this is going to reverse the number. So instead of us starting from 1 to 9, we start from 9 down to 1, which is a perfect way for a countdown as well. So we have 1, 9, 8 up to 1. So that's just it. Then the other one is creating an infinite loop. So let's say infinite loop. So a way to create an infinite loop, let me just give you this example. We can use a mute counter, a mutable number. So for us to break that loop, we have to actually use a number and stop it. So what we can do right here is to bring down the loop, and then we have the counter. We can start incrementing that counter. So remember, the counter started with 0. We can start incrementing it. But what we're going to say is when this counter is equals 10, all we just want to do is to break out of that loop and stop. So we can then say print line counter Structs adds, and you already know we pass the counter to the placeholder. So that's just it. So I've already shown you how to use a while loop, a for loop. But another way we can use a for loop is doing like divisions within that loop in order to actually continue or skip or stop that particular loop. So let me just give you an example. So we can say using a loop with continue. So we can actually say this is using infinite loop with a break. So using a loop with continue. So what we're going to do is for I, and we already know 1 to 10. So right here you could see we are using for I, which is quite cool. So we can say if I is divisible by 2 and it's 0, we can skip all the numbers that are divisible by 2, and then we can print all the odd numbers. So we can say odd number let's say odd number. I think this is best this way. We can just print I, and what this is gonna do is loop from 1 to 10. So skip all the numbers that are divisible by 10, and then print all the numbers that are not divisible by 2. Sorry, not 10. So let's save that, and let's kind of run because we didn't run the previous one. So let's start from right here. So we should get counter stopped at, so we could see counter stopped at 10, and odd number is 1, 3, 5, 7, and 9, because we are actually skipping all the numbers that are divisible by 2. One more thing we can do is to use the infinite loop with a condition. So let's declare a mutable variable called n, and we all know that we have to bring down the loop, and then inside this loop we increment that number, and then what we can do is if n, which is the number, is greater than 5, we want to stop that loop because this is an infinite loop. We just have to break, and then we can print line and say n is equals this, and then we pass a placeholder value. So I think I didn't close this properly, and one thing we can now do is to clear this one more time and then cargo run, and then we get n is up to 5, and then it stops. So that's just some basic example of loops, and I expect you to make some research, learn more about loops, and hit that like button and also the subscribe button. In this section, we're going to learn about function, how to pass down arguments to function. But initially, we have actually been using the exec function, which we created, and we made sure that this function was a public function. So we have the private function and also the public function. So if I remove this, for example, it becomes a private function which cannot be used outside of the scope of this file. But once I pass down the public to the name, then we can make use of this function at any other file. And it becomes available in our crate as well, in as much as we imported the file where it's accessible all over the project. So what I'm going to do is I'm going to create different kinds of function, and then we're going to see some examples of how to use these functions and also how to pass down arguments to these functions. So the first one I'm going to create is a basic function for greeting. I'm going to call this function greet, and then I'm going to pass down the name with a string. And inside this function, all we just have to do is to use the print line, and then we say hello, hello to the name, and then we pass down the placeholder value, which is the name as well. So the second function I'm going to create is a function with a return value. So this function is going to add two numbers. So we're going to assign a signed integer of I, 32, and also an I, 32. So one of the cool thing about Rust is, let's say for example, if we say a plus b, this is actually going to return the value of this a plus b. But one thing we can do is to make sure that it only returns only a plus b. So let's say only this data type, which we actually assign right here. So I can just say I32, and then it's going to ensure that what it's going to return here is I32. Now, if you watch closely, we are getting something like a white line under here because Rust won't allow us to add, close this out at the end of the line of the code, because automatically this is going to return the value even without us adding that. So that's one of the coolest thing I like about Rust, by the way. Then if we try to change this to another kind of value, you see automatically it tells us that this is not the data type that we have to return, so which is quite cool. So the third function I'm going to create is function with multiple with multiple parameters. So sorry for that cough. Sorry for that. So I'm going to say function display info. Then we have name, which is going to be a string, and then we have age, which is going to be an unsigned integer of 32 bits. And then we're just going to print line and say name, and we already have age as well. So let's kind of make this ops, and then we have the name, and then we have the age. So even if we close it out, it's okay because we are not returning anything. So we have function with optional parameters. So let's say we are supposed to receive a name, but sometimes we don't actually need that name. So we're gonna say function with optional parameter. Then we're gonna say greets optional. So we have name, and we're gonna just use the option. And what we're gonna do is to make sure that this is actually a string. And then, like I said, since we are making this optional, we have to use the match condition, which we just learned. So I will say match name, and we already know next thing we have to do is, but there's something new I'm gonna show you. For example, if we have some name fits into this, all we just have to do is to return hello, and then we pass that in. Or if we have none, all we're gonna do is to return print line hello stranger. So this is quite a little bit different because the other one is we did a direct match, but remember we sort of use a style of the switch statement to actually match word for word. But in this case, we are not matching word for word. We're only checking if we have something there or if we have nothing there. And that's why we are able to print each of these and display it. So the last function I'm going to create is a function for returning a tuple. So let's say function returning a tuple. So this function is going to be a square and cube of x, I 32 bits. And so as usual, you know, if we go on to return a tuple, this is going to like tell us to actually infer the data type, although it's not going to cause an error, but it's actually safe to always infer a data type. So let's just infer the data type instead, I32 and I32. So we can return x multiplying x and x multiplying the x multiplying the x. So this is square and cube. So this actually returns a tuple of the two integers for us. So right now let's go on and test our function because we've added a lot of function and we are going to test it on the exec function. So we can actually make reference of the greet function directly from here. All you just have to do is to type down greets and it's going to make reference to that function. So let's make sure that that works actually. Okay, the reason why we didn't get any recommendation is because this is not public, so it's just within the scope of this file. But if I add something like pub right here and come back right here, you could see we get a recommendation. And if we try to try that one more time, it works. And then the reason why we are getting this red line is because we've not actually added a string. So any name we add here, let's say for example Samuel or Bob, you see everything works fine. But what I'm going to do is to still stick to what we have so that we don't add so many functions right there. So let's just stick within our scope file, and then inside here, so what I'm going to do is to call the greet function. We don't actually necessarily need to print anything because everything is already printed in these functions. So I can say Bob, and then the second one we can use the add function. So let me just break this down and say let's sum equals to add. So let's say add 5 plus 5, and then we can actually print that. So the reason we are printing that is because we didn't actually print anything on the add function. So we can print something here, sum is, and we have sum. So this actually works fine. And then the third function we have to use is to display information. So we have name and age. So we have display info. So you could see Ross is commenting that for us. So the name is going to be a string. So let's say add Alice is let's say 25. And then we also have the greet optional. So oh sorry, this is not supposed to be in a string, this is pure number, so that's why the types are actually helping us not to make any mistakes. So we have one more, which is the greet optional. And so in this greet optional we have some, and then we have Alice, and we have one more, and we are gonna get rid of this, and we have none. So when we get some, this is going to run, which is down here, hello Alice, and when we get none, hello stranger. And the last one, which is the cube. So let's let's get the values, but first we are going to add a value to the add cube itself. So let's say square and cube of 2. So the return value, we are going to access it from here, which is going to be a square, and which is going to be a cube. So automatically we are returning a tuple, and we are just accessing the values directly. So we can print line square of 2, and then the cube of 2. So the square, so we can pass down the square, and we can pass down the cube. So with that done, we can just quickly run our file, but I think we are still getting one more recommendation. I think that is because in Rust, it's often recommended to use lowercase instead of you using like camel case. So we can change this to down, and then we get a yellow line off. So I think I like it. But when you're writing code in JavaScript, you prefer to use more of camel case. So you use that same approach in Rust. Rust is going to tell you, hey, let's make this lowercase. So let's run this code and see the results. And the first one is hello Bob. So we have hello Bob. The sum of 5 plus 5 is 10. And then we have the display info of Alice and its age. And then we have the optional. We have some Alice, which is hello Alice, and then we have none, which is hello stranger, and we have the last one, which is the square and the cube. So that's it for function, and if you have more questions, do not waste time to ask in the comment section, and I will attend to that. Thank you for watching now, and hit that like button and also the subscribe button, and let's see on the next section. So in Rust, we have something called pointers, and pointers are variables that store the memory address of some value. So quickly, let me just give you an example of how pointers work. I think we are not going to waste much time on pointers. And then right here, let's say we have an x, and this x happens to be 5. So all we can do is to say let y, and then we're going to point to the address of this 5 in the memory, and then assign that value to y. So if we print line right here and say y points to x, y points to, and then we just save this. So if we run this, so it say y points to 5 because y has been assigned the value of x. So that's just a basic example, but let me just give you one more example. And this example is called difference and modify. So let's say let's mute x equals to 5, and let y is equal to, so what I'm going to do is to use mute x. So what this we do is to make a mutable reference of x and assign it to the y memory. And then if we actually want to modify what is on x from this y, all we just have to use is to use the asterisk, and we can add 1 to it. So if I go on to print line and say x is now x is now x. So what it's going to do is actually it's going to increment the number of x. So let's run this. So you can see x is now 6, and if we run y, you can see it still makes reference to that x. So that's one way to actually edit the memory of x using the asterisk in front of y. So that's just it for pointers. Let's go on and read a file in Rust. The first thing we have to do is to import the file from the standard library of Rust, from the file system. So this will be used to import files and make sure that we're able to read the contents of that file. And then we have to import the readers, which is from the input attributes. And here we have self, we have the buff read, and then we have the buff reader. Inside right here, we're gonna sort of add some things to this function because we want to make sure that when there's an error, we're able to display that error, and when there's a result, everything will pass smoothly. So I'm just gonna use the input output stream. I'm going to grab a results, and then I'm just gonna add a parenthesis. So what I'm just gonna do is to come here, type down OK, and add another parenthesis. So if there's an error, we are gonna catch that error. That's the reason for that. So let's file equals. We're going to open that file with our file, and we're going to make reference to our example.txt file that I created. So we're going to add a question mark here so that if we have any error when we are trying to import that file, we are going to catch that error immediately because we don't want to create a custom way of catching errors yet. And then we're going to read the contents of that file. So I'm going to save that. So what we're going to do is to loop through the lines of that file, which is going to be for line in reader.lines. So we have to print line, and then we can pass down that line. So the reason for that is because we also have to catch an error. If there's an error, we display it once. So let's go on and check our example.txt file. I just created one and then added an hello world inside our example.txt file. And let's go on to run our file. So you could see the content of that file called hello world. So this is just a basic simple way to read the file in Rust. And I think you enjoyed it. So make sure you hit that like button and also the subscribe button. So right now we are trying to write a file inside an output file we're going to create. So let's quickly create an output file called attributes.txt. So we're going to write some things inside this file. So what I'm going to do is to first of all import the necessary things like we did in the read file. So we have the file from the file system and also write from the input attributes, and then we follow the same convention which helps us to catch an error when there's an error and display that. So let's use mute file, and then we're gonna create a file called attribute. Okay, I already did create that, but we can actually get rid of it and stick to this. So let me get rid of this right here, and then we're gonna write some line inside that file. So we can write hello world, and we can write something else as well inside that file. You can say this is a new line of text. So right here we're getting an error because we didn't add the question mark there, and also we have to add this question mark in case we get an error. We just want to simply display that error ASAP. So let's run cargo and see what we have. So that was supposed to create a file for us, but what I can do is to create this file inside the source folder because it's created it outside the source folder. So let me just get rid of that one, and let's run cargo run one more time, and then it creates it inside this output.txt, sorry, inside the source folder, and then right here you can see we have hello world and the new line of text. So that's just how to create a file in Rust. So we've actually learned about tuples, used it in one or two examples, but right now let's dive into arrays. First, I'm going to create a public function as usual called a sec, and that should get rid of that red line. And right here, let me just show you how to declare an array. So I see I'm making a lot of mistakes because it's been a while. well, I'm still also trying to minimize a lot of these mistakes. So we have 1, 2, 3, 4, and 5. So you could see we have one data type. So if I, let's say, change this to a float, it's kind of tells us that we can have multiple types of data inside this array. So let's just stick to what we have, because this is not a tuple. If it's a tuple, we can have different type of data. So let me just go on and print this and say the third number is, so as usual we have number 0, 1, and 2. So if it was a tuple, we could have said number dot and then we get 0, 1, or 2. So when we try to create this first array, we actually got this inferred directly to us, but we can actually do that by ourselves. So let's say array with explicit type and length. So we can say let letters, and so here I just want to declare a character of array length of 3, and it has to be A, B, and C. So if we try to add something like a string here, it's not going to work because we are sticking to a character. So if it's actually a string, we have to use the ampersand and then the str to ensure that it's a string. So we can say print line first letter, as usual, letters, and 0, and that's going to print the first letter. So when we are done, we can run this to actually see how they all behave. But you could see so far there's no errors and everything seems fine. But as you're learning, you can also run these codes to actually see how they behave. So let's also initialize arrays with the same value. So let's say array initialization with same value. So let's say zeros, and then we have 0 into 5 places. So it creates an array of 0 into 5 places. So we can print line array of zeros, and as usual, we can actually display this with, let's say, for example, zeros 1, but in this case we want to display everything inside the 0. We use the debug style of printing things, which is a colon and a question mark, and it's going to print down everything inside this array for us. So as we all know, creating an array with different kind of data types is going to cause an error. Let me just give you an example. Let's say array with different data types. So let's say mixed, we have 1, then we have 2, and then we have a character. So definitely this is going to cause an error in Rust, because Rust won't allow us to do something like this except with a tuple. If it's a tuple, it's going to work pretty fine. There's not going to be an error, and it's going to allow you to do that. So let's just leave that and still proceed. Let me just undo and comment this out. So let's say we want to iterate through an array, and you already know we have numbers at the top, so we're going to make use of that numbers. So we can say array iteration for number in numbers dot iter. So we can print line number is, and then we just have to pass the num right there, and it's going to iterate through these numbers and then display it for us. So lastly, we are going to pass down an array into a function, and the way we can do that is to create a function called print array, and then it's going to accept an array with its data type. So right here we can say for I in array dot iter, we want to print everything from that array. So we can save. So for us to make use of that, say passing an array to a function. So we have print array, and then let's use numbers. Numbers, not number, sorry. So this is giving us an error because the array expected only 3 elements, but we are actually passing more than 3 elements. So let me just kind of use 1, 2, and 3. Yeah, the error goes away. So that's how we can make use of arrays. So right now, let's go on and run, and I hope we don't get any error. Oh, sorry, not cargo, just cargo run. And everything worked perfectly fine. So you could see the first, I think the third number is 012, which is right there. And then we have array type of 0 up to 5. We have the second one, which is the first letter 0. Then we have array we initialize up to 5. And then we have the iteration that loops through each numbers from the array. And then we display the array with only 3 elements. So if we actually commented this out to run our code, you could see it can't even compile because we already have an error being displayed. So that's it for an array, and thanks for watching. So tuples, which are similar to arrays, are a bit more helpful in handling multiple data at once. So let's just go on and give you some basic example. We can actually use tuples to do a lot of things. First, I'm going to create my function called exec, and inside my function, I'm going to save that to get rid of that red line. Now let's declare a tuple. So of course, we've actually come across this example, but right now we just want to like dive into tuple, really understand how things works, and learn more about it. So the first one is going to be an unsigned integer of 32 bits and a float of 64 bits and also a character. And we can assign numbers to it. So let's say 2.5 and a character of hello. Let's use H. And we can actually print, I think, a character. What did I get wrong here? That was actually supposed to be a character, or did we get anything wrong? I think, oh, okay, yeah, I forgot. Tuples don't accept double quotes, so only single quotes. Yeah, so we can print age, and we can add a placeholder, and we can print height. We can also add a placeholder, and we can print gender. And let's make this female, and we can also add a placeholder. And in tuple, for us to make use of that, we can say person.0, person.1, and person.2. And when we save that, we see the error goes away and everything can work. So we have age, height, and also gender. Then the other way to actually access these values is to use a destructuring style. So let's say destructure a tuple. So let's add parentheses and reference the person. So if we actually want to access the age and all the values there, we can say age, height, and of course, gender. So this is also another way to display that, and we can quickly get rid of these things. Have age, height, and gender. So this is also going to give us the same result. So let me correct that and save that. So that's a way of destructuring things in tuples. So we can actually swap values in tuples. A very good example of that is let's say we have A and B, and this A and B is 5 and 10. So let's just give this a comment, swap values using tuples. So we have the print line, and before swap, we have A to be this, and we have B to be this. So we already have A and B, as you know it. And then we have to declare something, and what we're going to do is a tuple rather, and then we can swap these values, like switch them around, and then we can still access it with A and B, and then we can say after swap. So when we run this code, it's going to like take the 5 and assign to B, and take the 10 assigned to A. But before that, everything was the way it should be. And then let me try to give you more example. Let me say, okay, let's do something like a calculation. Let me write a function called calculate, which is going to accept an assigned of 32, and B, same thing, I32, which is going to return a tuple. I think we already did something similar to this in one of our videos. So we have A plus B, and we have A multiplied by B. So this gives us, when we actually make use of this, it gives us the same thing. So let me just quickly make use of that. Let's say calculate, and I think we already have AB somewhere. Yeah, we can see use of our AB out there. And then we have the sum and the product, and we can print line. So sum and product. I think we are getting what I'm going to do is to add 2 here, add 2 here. So let's try to minimize us having an error. And product is this. So we have the sum and the product. So I don't actually know why we got that, because I expected the A and B to still pass down. But regardless, everything should work fine. So when we sort of run our code, okay, right here I actually kept something like a struct out there, but I think it's not the best time to actually bring this up. So we're going to talk about structs in one of our videos, and you're going to learn how to use structs with a tuple. So let me just get rid of that and then run cargo run for now. So everything worked pretty fine, just as expected. So we have age, height, gender, and then we have age, height, and gender as well. And then we have to swap the value. So before swap, A was 5, B was 10, but after swap, A was 10, B was 5. And then lastly, we have the sum and the product. So even if we take this function and put down here, it's still gonna work fine, because we don't actually have an error there. So let's clear this, cargo run, and everything worked as expected. So vectors are sizable array-like collections that can store only the same type of data, just like arrays can only store the same type of data. But vectors are sizable in the sense that they are dynamic, and they can accept as many data and also remove as many data. So let's go on and give you a very good example of how they work. So let's create a vector of colors. So let's say mute colors vec. So we have green, we have blue, and we usually start with red if you actually understand where I'm coming from. So we have red. So you could see right now we are getting that error because they don't accept single quotes, just like tuples, they only accept double quotes. So if we go on and change this to double quotes, everything is going to be fine. So let's just go on and print initial colors, and we have colors. So actually it will work with using an index to access each element in the vec, but what we're going to do, we want to display everything, so we just use the debug style to print out everything, and it's going to still work fine. So right now we are getting immutable blah 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 error. That's just something because we want to actually be able to manipulate the element in this vec. So let's go on and remove an element from vec. So we can say colors.pop. So this is going to remove one element from our vec, and if we print again, so we have colors after pop, and then we print everything, and we have to use the debug style to print it. So let's go on and run this and see the results. So the initial colors was red, green, and blue, but when we popped, we removed the last element, and then we only returned the green and blue. So let's go on to slice our vec. So let's say vector slicing. We want to remove the last one from the colors rather. So what I'm going to do is I'm going to copy down the main colors, and then we slice off the last one. So let's create a slice. Oh, sorry for that. And then we can copy down our colors. And what we want to do is to slice off the last one. So we want to start from the 0 index and stop at the 2 index. So with that done, we can print line and then sliced colors, and then we pass down our slice. So we have cargo run, which is going to slice off the blue color from the vector. So another way to also add to our vector is to use the push style. So let's say create and push to a vector. So let's mute equal to scores. So this is more like a sort of creating a dynamic vector, but I like it because let's say you initialize an empty vector and then you add to it, which is quite cool. Let's declare the type. So this is going to be a vec of I32, and this is going to be a new vec. And then we have scores.push. So we can push a value, let's say 20. We can also push more like 80. Let's push like 200. So we have like 3 elements inside the vector, and then we can print line scores, and then we display that scores inside that placeholder. So anytime we want to access an element inside a vec, we can use the indexes to access it. So let's say accessing vector elements. So let's first score, and then we can say score 0, so we can access that. And if we print line, we'll say first score, and then we have the first score. So for this particular one, I don't think we actually have to use the debug style. This is okay the way it is, and we can actually loop over or iterate over our vector. So let's say iterate over a vector. So as usual, we've done the for loop, so you understand what we are doing. So for score in, so we copy down the scores, and then we can print line score, and then each score goes in there. So let's clear this and run cargo run, and everything worked perfectly the way it should. So that's it for vector. If you've come this far, make sure you hit that like button and also the subscribe button. So far we have learned about tuples, array, and vectors. So right now let's learn about hash maps. So hash maps enables you to store values or store data in key value pair order. So before we proceed, let's go on and import from the raw standard library. Let's bring in the collection, and we can make reference to the hash map. And then inside our exec function, let's create a basic hash map. So this is hash map. So just like the way we initialize a dynamic array, in this case, we are going to initialize a new hash map. So it's sort of dynamic because we can insert, we can also remove from it. So what we can do to insert is to make reference of the scores. Let's change this to scores dot insert. So we want to insert the key and the value. So we're going to use a string from, let's say blue. I'm going to change this to 10. So with the help of this, we can insert a value into our hash map, and we can actually insert another one. Let's say yellow. I'm going to change this to 50. So even if we go on and print line, sorry for that, print this out, we have to use the debug style, and then we just have to pass on the scores. So let's go on and run this. So we can see the objects, yellow 50, blue, and 10. Let's go over to accessing value from this hash map. So what I'm going to do, I'm going to change this to Bob, and I can change this to Sam. So in order for us to access these values and not just print it like this, let's say accessing hash map. So what we're going to do is we are going to create, let's say, a score variable, because we already have a score, and in this score we're going to use a string and then from. So what we're going to do is to pass the Bob key right there, and then let's say name rather. So let's go on and assign this to a score. So for this score, in order for us to access the value, we just have to simply say scores.get, and then we just borrow that name. And once we borrow that name, we can go on and print line. So I think I even have to like do this. Okay, this is not gonna work because hash map always returns something like sum. So let's do cargo run, and we get sum 10. So if I change this, if I remove that, let me see if it's gonna work. So we get that same error. So it's not even gonna allow us to pass down the placeholder. So we have to make sure that we always use the debug style to ensure this works perfectly. So we can see the score shown to us. So let's go on and iterate over this hash map. So I always use lowercase, but always remember you have to make this a camel case. So if we want to loop over a hash map, we want to access the key and the value in. I guess you already know that we have to borrow the scores. So if we go on and print line, let's say key and value. So if we go on and pass down the key and the value, we are able to access that. And when we run the code, we get key and the value. So I think we are getting this because this is kind of redundant, and I don't want us to do that. So let's go on and run again. I think we have one more redundant code there. Yeah. So let's clear this and run this one more time. I just want to get the result. So we have a key and the value, key of Sam, and also the value. So let's go on and update something in our hash map, updating a value in hash map. So what we're going to do is reference our scores.insert. So you already know we have a name there, which is Bob and Sam. We can use the string from, we have Bob, and then we assign the new value to Bob. Bob is 10. We can change Bob to 20, and also we can do the same thing for Sam and change this to let's change Sam to 100. And if we go on and print scores, we should get the new values shown to us. So we get Bob 20 and Sam 100. So let's do one more example, merging two hash map. So let's declare the hash map 1, which is gonna be a hash map, and then we initialize that new. So what we're gonna do is to insert something into this first hash map. So let's insert something like a string from, let's say, fruits. So let's use something like apple, and then let's declare map2. It's gonna be hash map new, and we can say map2.insert string from, let's say, food. Let's give something like a soup. So if we want to merge these two hash map, all we just have to do is to map1.insert, sorry, dot extend, not insert, dot extend, and then we can reference map2. And if we go on and print this, I think we didn't close this out. So if we go on and print this right here, so we are getting yeah, because map2 has to be mutable as well. Yeah. So if we go on and print map1, we should get both values, which is map1 and map2 together. So let's clean this and run that one more time. So we get fruit, apple, and food, soup. So this is the last example for hash map. I guess you really understand how hash maps work. You can still go around and check more example by yourself of how you can use hash map, and I guess you've really learned a lot. So before you proceed, like this video and also subscribe to our channel. By now you already know we learned some things about iterators in one of our videos, especially when we learned about the loop. But right now let's go in depth on iterators and really understand how to manipulate the elements of our vectors or the elements inside of our vectors. So what I'm going to do is to create numbers. So let me just say this is going to be an example of mapping over a vector. So this number is going to be a vec of 32 bits numbers. So as usual, you know we're going to bring a vec and then pass 1, 2, and 3. So let's go on and save. So in order for us to iterate and then let's say do some multiplication on this number, we have to use the iterator. So let's say doubled. So this is going to return a new collection of I32, and what this is going to do is to use the numbers. So let's break this down. So iterate over these numbers, and then we bring down the map. So with the help of the map, we can use the closure and say, hey, this is x multiplied by 2, and then we return this back to a new collection and save. And if we go on and print this, so let's print down the doubled and cargo run. So we get each of the elements multiplied with 2 by the help of this map closure. So let's go on and filter a vector. As you all know, if you're coming from JavaScript, it's kind of similar to what we do there. But this time around, I'm going to introduce something to you called into iter. So first of all, let's go on and still use our number. But right now, let's declare our variable called even numbers. So even numbers is going to reference numbers. And as usual, you know, we always have to assign the vec type so we don't get an error of 32 bits. And then we're going to use something called into iter. So the reason I want to use into iter is I want to just quickly give you an explanation how this differs from this. So with the help of the iter, we just borrow the values and still do what we want to do, which means we can reuse the numbers. But when we use into iter, we can't reuse these numbers, which means every value is now, every other thing from numbers is now moved to even numbers at the end of the codes. I mean, like when they are run. So we can now say into iter.filter, and as you know, we just have to bring in our closure x. And we can say we only want to access, we only want to get all the values that are divisible by 2, and then we create a new collection from that. So if we go on and print even numbers, so let me just copy this down and change this to even numbers. And then we go on and run our code. So we only get the number which is divisible by 2. So right now, like I said, we can't reuse this number. If we try to reuse this number, we're gonna get error. So a good example of that would be, for example, let's say we copied this, and even if we change this to mute and then copy that, because I just want to try to shadow this and then see, let's see what's gonna happen with the number. So you could see right here, it's gonna tell us borrow moved value numbers. So right now we can't reuse this number because Iterators has moved all the values of numbers into the even numbers. Let's use what is called a filter map. So we're gonna use a filter map to filter and transform. So let's declare strings, and then let's say this is going to be a string of text and also numbers. So at the end of this example, we just want to filter out only numbers, only the strings that can be passed down to numbers. So I'm going to create a vec here, and this vec is going to contain a lot of things. So let's give an example of Bob. Let's say 20, and then let's say 10, and then let's say numbers. So like we all know that we can't redeclare numbers because right now we are not able to access numbers because of the Iterators that moved every value to even numbers. So with that, numbers is going to return a vec, and we want to return a vec of 32 bits. So with that, we can say strings. This is strings, not string. Strings dots. So we have to use the Iterators. So I think I should break this down. So Iterators dot filter map. So with the help of the filter map, we can use the closure as usual, and we can say else dot parse, and then we pass the OK function, and then we create a new collection from that. So if we go on and print numbers, so let's run this to see the effect. So we only get 20 and 10 because we can't pass Bob down to a number. Let's go on and learn about chaining iterators. So this allows us to use multiple iterators on a vec. I'm going to declare numbers, and these numbers are going to be vec of 1, 2, and 3. And what we're going to do is to declare a result. Then we're going to assign a vec of I32 because we're going to return a new collection from that, and then we have to iterate over our number. So we borrow. So the first one we can do is to map, and then let's say we just perform some actions. So let's say x multiplied by 2, and then we can filter, and with that we can say x. We want to filter the value that is greater than, let's say, a little bit above 4. So let's use 5 for example. So I'm just gonna put down 5 here. So if I try to put this 5 directly, it's not gonna work. It's gonna give us an error. And then I'm just gonna create a new collection from that. And if I go on to print line and then results, so let's sort of run this, and we get 6. So that's just an example of chaining iterator. One other thing we can do is to find a particular value. So find a particular value in a vec. So the way we can do that is I think we still have our numbers, and let's say, let me declare find results. So find results is going to iterate over the numbers, and then we're gonna find. So here I'm gonna use double ampersand, and now I can say x is equals to, And with that alone, we can go on and print line, and we have our find results. So if we go on and run cargo run, we only get the results, so it returns sum 2. So there are other things we can do with iterators, and I think that's it. And one more thing we can do, but I will leave this for you to go and learn about it, interact with it, and have more understanding. Is called reducing a vector to a single value. So this can be your test. Just take your time and learn about how to work with iterators. A struct in Rust is similar to a way tuple is, but in this case you have to define the way data has to be stored in structs. So let's go on and give you an example of defining a struct. So I'm going to start with structs, and then we're going to call the struct of user. So we have the username, which is going to be a string, of course. And then we have an email, which is also a string. We have a sign-in count. So this sign-in count is going to be a number, and of course, this number is not going to be a negative number. So we have to ensure that it's an unsigned integer of 64 bits or 32 bits, regardless. At least you understand why we're saying this. And then we have active, which is going to be a bool, which is a boolean. So that's just a basic way of defining a struct. So we're going to define a couple other structs. Let's define one more. I think let's define 2 more instead. So we have i32 bits, and also 32 bits. And we can define one more struct. So let me just define a struct called rectangle. It's going to have a width of unsigned of 32 and a height of unsigned bits of 32 bits. Then making use of this struct is very simple. Let's declare user1, and so we have our struct of user, which is going to be equals, so we have the user struct, and of course we have the username, and the username is a string, which is going to be a string from, so let's say Bob. So we have an email, which is also going to be a string from, we have bob@email.com, and then we have sign-in count. So the sign-in count is going to be an unsigned bits of 64 bits. So if we try to use -1 or -2, it's not going to work. And then we have an active, which is a bool. So let's go on and save, which is a boolean, which is either true or false, not actually a bool. So right here you could see our struct has been used to define these values. So if we, let's say for example, want to print our username and say username equals so what we can do is user1.username, and this is going to print our usernames. And I can see that we are getting redundant codes. That's because we are not making use of everything here. So in case you're wondering why we are getting redundant codes here, that's because we are not actually making use of the email. So if we say print something like email, and then let's say user1.email, you could see the yellow line gets off the email. So we can still go on and print the remaining one, which is the sign-in count and active. We can change this to active and sign-in count. So when we save, we could see we are making use of all the struct values, and the yellow line gets off. So let's say we want to update the value of this email from our struct. What we can do is to declare another variable called user2, and we can reference our struct. So let's say on the email, we can say new bob at email.com, and then we can spread our user1. think did I spread this much? Yeah, so this is supposed to be double dots, and this is supposed to also be a string. Sorry for using a direct string from this. So this is supposed to be string from new Bob at email.com, and the error goes away. So if we try to print email from user 2, so we should definitely get new Bob at email.com because we have actually updated the email. So let's do something similar to a tuple, and let's call it tuple struct. So usually unlike tuple, you have to declare the variable, and then with your parentheses you can include your values. But because we have a struct, all we're gonna do is to declare a color of black. So we can say color, we make use of our struct 000, and that's just it. And if we print line, let's say color 1, 2, and 3, as usual, you can just use black 0, black 1, and black 2. And we can save that, and if we try to run our codes, so we get color 0, 0, and 0. So we still have one more struct left here, which is the rectangle, and I left it for a reason because I want us to understand what are called implementations in Rust, which allows us to define a function for a particular struct or enums. So what we're going to do is to come here. I'm going to write down impl, and I'm going to name it after that struct. And what we're going to do is to define a function called area, and inside this area we're going to return a 32-bit calculation. So with the help of self, I'm able to pass down the reference of this width and height. So what I can do now is self.width multiplied by self.height, and I'll go on and save that. So we have a function for this struct, and for us to now make use of this area, all we just need to do is to, let's come down right here and declare a variable called rect1. So let me just comment this use method from structs. So we have the rectangle, and we have the width and also the height. So of course, we can actually print this, and it's going to print just the struct for us. So for us to now make use of the function that we declared for this struct, let me use that inside a print line. So area of rectangle is so let's say rect1 dot area, and let's go on and run our codes, and we should get area of rectangle is 600. So with the help of borrowing, we are able to make use of these values from our struct reference, and then we made a little bit calculation on that. So now we are done with structs. We are now over to enums. So enum is like a type that allows you to declare possible different or several values which you can actually use when you are working on your codes or writing your codes. So let me just go ahead and give you a possible example of enums. So let's say enum of direction. So we have 1, which is up, down, we have left, and also we have right. So this is just an example of enum. We can also declare another kind of enum for coin. Let me use capitalized words. So we have penny, we have nickel, we have dime, and we have Bitcoin. So we can also declare enums for custom data. So let's say enum of message. So let's add something like quits. We have move, and here I can pass in the XY values of move move XY values. So if you are a game developer, you sort of understand me. And I think we are getting that because we added a colon there. So we have also write, let's say this is going to accept a string, and we have change color, which is going to accept 32 bits of 3, maybe red, green, and blue. So I did add a comma here. So we can actually declare an implementation and then declare a function for a particular enum. And to do that is just to bring down the implementation block, and we reference the enum, and we can create a function called value in cents. So we can use the borrow, and we return an unsigned of 32 bits. So we want to use something like the match statements to match each enums that we actually receive. So we have match self. Then the first one is going to be a coin of penny. We return 1 enum of nickel. We return 5. Then enum of dime. We return 10, and enum of Bitcoin we can return maybe 70k, which is 70,000. So that's how we can declare an implementation for an enum. So right now let's go on and use our enums that we created and test each of them to see how they behave. So the first one we have to check is the direction enum that we declared at the top. I'm going to create a variable called go, which is going to make use of a particular enum. So we just have to reference that, and that's how we can use that enum. In order for us to use an enum with data, let's say enum with data, you remember we have a message enum, and then we have a move, and we can assign values to x and y, which is 10 and 10. And that's how we can use an enum with data. So let's kind of check our enum in action. I'm going to create a function called process message, and this process message is going to accept some argument called message from the message enum. So we're going to match that message, and for each enum, let's say message.starts. So we can add start right here. And we can also add stop. So let's say enum.starts. We want to print line, which is starting. And are we getting anything wrong here? So I think it's not allowing us to make use of this because it's expecting us to actually add a lot for each of these enums. So what I'm going to do is I'm going to comment this out and also comment this out. I think let me try to add one more, which is a message stop. So we have print line stopping. So let's save that, and then that gives us a init code that we can run without giving us an error. So making use of this enum now, all we just have to say is to call the process message, and we can pass message and start. Of course, you know, when we run this code, we are going to get starting. So we do have a lot of yellow lines, and it's being shown here, but regardless, we got our starting to show us our enum in action. So go on and create your trait file, and then import your traits on the main file, which is from the mod. So we have to import the traits, and as usual we have traits, and then we call our exec function. So we can create our public function exec. So what are traits? Traits acts like guides for a particular struct, and then because of these traits, your functions or your implementation blocks must implement the trait inside a particular trait block. So let me give you an example. Let's say we have a trait of summary, and then we have a function called summary. So we just make reference to self, and this function is just gonna return a string. I think, yeah, that should be it. It's gonna return a string, and for us to make use of that trait, we have to create a struct. So let's create a struct of article and give it a title and also a content. Then we have to bring down the implementation block and implement a trait for this article. So implement summary for article. So for us to do that, that means that this summary block must implement the trait. So even if I use the auto recommendation to implement the missing members, it's going to implement that trait. So we can still do that. And the next thing we have to do is to return a string. So the easiest way for us to return a string is to use the format macro, and then let's return a string there. So let's say self.title and self.content. So this alone, it's enough. In order for us to now use this article, we just have to come down into our exec file, and let's declare an article called article. So we have title, so this is coming from our structs. So we have title, and as usual, string from. So let's call it Rust traits, and we have content, string from. So let's say a powerful feature in Rust, and the error goes away, so we can go on and print that, and so we have article.summarize, and when we try to run that, that should actually work, but we are getting an error because this is supposed to be a string, not just a small letter string. And then we get Rust traits, a powerful feature in Rust.